Record this.
This meeting is being recorded.
Okay. Can someone summarize yesterday class for me, please?
Yes, so yesterday we discussed about the configuration between at site to site VPN. So there will be two phases in that. In phase one, there are 5 parameters like IP address exchange, encryption algorithm, pre-shared key authentication header and DH group. Then we discussed about the ACL, that is access control list. And there are two types in the ACL, standard ACL and extended ACL. Yeah.
What is an ACL? Why do we use it?
It's a gatekeeper, it blocks the traffic or it filters the data or during the transmission.
It's nothing but it will be allowing or denying the traffic based on the condition that is defined by the administrator. So if there is a traffic that we wanted to deny with an IP address, we can use a static or the standard IP access list, right? But if we want to deny as per the application or the port level, we can go with the extended
access. Yeah.
Thank you. And also yesterday we discussed, as Kanish told, we discussed about IPsec tunnel. So IPsec tunnel is nothing but when there are two sites and they wanted to communicate over the internet with a secure connection, there will be a tunnel formed between both the sites. So to accomplish that, first we have to trust the other site using the phase one. Phase one is for basically for negotiation. So both the sites will negotiate the parameters, make sure they both agree on certain conditions, and then they have the connectivity happen at the phase one. Then phase two is for the actual users to talk over the tunnel. It's just like building a road. On top of that road, we will build the, on top of that road, we can send the actual cars over that. Hey, I'm in training class. Can you call me back?
Oh, okay.
Sorry, someone called me. Okay. So basically phase one is like connecting two sites using a road, right? When you have two locations and when we wanted to connect them, we will build a road. And on top of that, the cars will go, the bicycles will go, the buses will go, right? That is the actual data traffic. So in similarly in the IPsec tunnel, the phase one is for communicating two sites. They both negotiate parameters and they form a tunnel between them. On top of that, the actual user traffic will flow. So that's what we discussed. We also discussed about the different types of parameters, what are being exchanged between them. And we also have seen, explanation of each parameter, like what is encryption, what is authentication header. I think we also went deeper and we also discussed about, what is an DH group, how do we use the DH group, how do we use the DH group to encrypt the data. We have seen that. At the ACL also, we discussed about, difference between an ACL versus a firewall, or what is a session table, how does the firewall keep the session by using the 5 parameters in the session table. We discussed that. So I think we did deeper, thorough on those topics yesterday, right? And today we're gonna move on from those topics because we did good on that. And next thing we will discuss today is about wireless concepts. Wireless is a little different concept because until now we discussed about wired protocol, meaning I coming into a site, I plugging in my laptop to a switch, or plugging in my laptop to a router, or plugging my server to a switch or router. We discussed those kind of scenarios, but Wi-Fi is something that does not require any wires. It is wireless, right? It does not need any wires. So it works on the data transmission over the antenna. So antenna will send the signal over the air and your receiver will catch it. It's just like you listening on the radio, right? You have a transmitter with an antenna, the sound will come over that, and then you can hear that, and you are the receiver here. Similarly, when we talk about the wireless, your router that you purchased will have antennas, right? And that will send the signal out over the air, and your laptop will have a receiver to catch that. So today we will talk about wireless a little bit. We don't, because this is not a CCNA wireless, or we are not doing the network wireless engineering, we don't go deeper in that. But that is also a big technology. It itself contains thousands of topics, but our agenda is not wireless in this course. But CCNA, as I already told, Cisco thought that the engineers, the basic level engineers should have knowledge on each and every topic, so added those components into the CCNA. But previously, if you have written the CCNA in 3-4 years back, you wouldn't have seen these topics. But Cisco added more flavors to it, and they wanted to combine everything into one base level course. Okay, so now let's talk about wireless a little bit, and then we can also discuss the wireless security a little bit, and also how we can protect the wireless in the real-time scenarios. Let's see how much we can cover for today on the wireless topic. Okay. Any questions before we move on?
No, sir.
Okay. So before we start wireless, let's talk about the various frequency ranges, right? So as I mentioned, start with sharing the screen. Okay, so we will talk about radio frequencies. Today class will be a lot of theory, because at the CCNA level, it is all theory for the wireless. We don't deal actually in the protocol level. It is more the theory level. So bear with me. If you have any questions, please feel free to ask, but this will be a little bit theory, okay? So radio frequencies are like at what frequency you can listen the signal, right? I think you already might have known what is frequency, right? So can someone tell me what is frequency?
A range of network.
No, I'm talking about the regular frequency, right? Like, for example, if you take period of time, like let's say 0 to 5 seconds. In these 5 seconds, how many waves that are totally propagated is the frequency. So for every 5 seconds, I have 1, 2, 3, 4, 5 iterations of the signal, right? So for every 1 second, we can see one full signal that is transmitted. We can call that, right? So frequency is described as number of waves that will be passed in a fixed place in a given amount of time. So in this place, how many signals it can pass in this amount of time is called nothing but the frequency. So that is same as, like, if we use that in the concept of radio frequency, the radio frequency is same as that, but here instead of these waves, the radio signals will propagate or progress in the time of the tunnel. Okay, because our network wireless signals work on radio frequency range. Okay, and what are those ranges? There is 2.4 gigahertz, and there is a 5 gigahertz. Okay, so that those are the ranges at which the wireless signal will be propagating. Okay, the main difference between 2.4 and 5 gigahertz is the coverage and the bandwidth. So that is the main difference, meaning like 2.4 band can provide like longer range. For example, let's say you are in a conference room. Okay, there is a big conference room. Okay, and if you put one 2.4 gig router here, which has 2.4 gigahertz antennas, right? If you put that, this antenna can cover the entire conference room because it has long range. Okay, the signal will be propagated, will go to the long range. Okay, but if you use the 5 gigahertz, it will only cover half of the room. It cannot cover entire room, but it has the capacity to go with high speed, right? So lower speed, but longer distance. Think about like 5 gigahertz is like a rabbit, right? It can go faster speeds, but it cannot go like longer distances. It will stop in the middle and take a nap. But 2.4 is like a tortoise. It can go longer distances, but it will go slowly. Right? So think that as an example. 2.4 will be having the longer range, but the data transmission rate is slow. The opposite is 5 gigahertz. It will provide less coverage, but the transmit rates are at the faster speeds. Okay, and there is a table and there is a standard for each. This is all theory. So you don't have to by heart this unless you are applying for a wireless network engineer position. You don't have to by heart this. You can just Google this stuff, but for the class, I have to write it down. So please bear with me, okay? So this is called band or standard. And this is, let's do it this way. Standard. And then here deployed. And then bands, what they call maximum speed can achieve, right? So first, it is called 802.11 band. I think it was first deployed in 1990, somewhere like 6-7 range. It is 2.4. The maximum speed it can go is up to 2 Mbps. They improved the standard to 802.11b. That was in 1999 year. And then 0.4 gigahertz can go up to like 11 Mbps. So they launched to 5 gigahertz, right? It can go up to 54. Then they wanted to advance the rates of 2.4 as well. So then in 2003 or 2004, that time frame, They came up with 2.4 again. They increased the speed to 600 Mbps. Oh, no, my bad. Before Mbps. Right, so in 2003 they advanced to 2.4, it went to 654, and then in 2009, I believe, yeah, 2009, they went to both. It supports both. They went to always up to like 600 Mbps. Okay, the recent one, I mean not recent, but comparatively recent, 2013 or 2015 time frame, that range, they came up with 5G network, 5G heads, right? It can go up to like 6 gig, almost 7, think like 6.9 to 7 gigabit per second. And then the last one, I think they also went with, after this, they went with the other one as well. So they went to 2019. They advanced both. They can go up to like 10 gig to 11 gig. And at the same time, at the AX, they also went with 6G, right? 6G network. Have you got, if you have guys have used Wi-Fi 6, that is same as AX. Wi-Fi 6. Right? You can go to 10 gig. So how can the how did these guys achieve? They achieved using multiple technologies like reducing the chip size, increasing the logic behind signal propagation. It is all math. That's how they should be able to. It's just like previously they used to have pen drives for like 1 gig, but now you can see the pen drive for almost like 25 gig, 50 gig pen drives, right, with the same cost. How did they achieve that? Using the better chip quality and ASIC improvement and improvement in the semiconductor technology and also improvement in the algorithm that they use, right? Similarly, they were able to achieve these speeds with the improvement in the next generation technology. These are all standards, guys. You does not need to remember this unless you are preparing for an exam to answer it, or you are doing an interview. Mostly they will not ask you about years at all, but they'll ask you like, hey, what is the difference between A versus B versus G? That is the most commonly asked question. Or they'll also ask, tell me about the data speeds of B, or they'll ask you like, what is the difference between 2.4 versus 5 gigahertz? They'll ask you like that. So just for that, remember that. And the next thing is the channels, right? Let's talk about the channels. Any questions? I think this is not much, but do you have any questions on this? Okay, let's move on. Is it sleepy? Are you guys sleeping?
No.
No.
I know it's very boring. Okay, all right. Next thing is what? Sorry. Okay, channels. I'm sleepy. Okay. Let's say there is a wireless router, right? Wi-Fi, right? And then let's say there are 3 users. This guy want to use the Wi-Fi, and this guy want to use the Wi-Fi, and this guy want to use the Wi-Fi. But what if they all want to use the Wi-Fi at the same time? Don't you think over the air there will be a collision between these guys? Obviously, because it's an open spectrum, it's like an open air. There will be signals that we cannot see in the air, right? So, but all these guys will collide. So, to avoid the collision domains, just like in a broadcasted VLAN, in a broadcast network, we separate them into multiple VLANs. Similarly, we will have channels to separate non-overlapping between the users. Okay, that is called channel. So channel is nothing but to separate the user connectivity in the wireless, and also let's say there is two access points, access point A and access point B. And access point B, A is sending a wireless signal to all the users. Similarly, within the range of the access point A, there is another access point B. It is also sending the wireless signals to its users, right? The connected users. So there will be a collision between these access point and this access point, and the signal will be degraded. To avoid that, we need to have non-overlapping channels. Okay, I will repeat again. So when there are multiple access points, to make sure that one access point signal does not collide with other access point signal, we will separate the signals in different channels based on their radio frequency. A channel will separate them to avoid the overlapping. Okay, so these channels are industry standard. So every 2.4 gig will be having set of channels which are non-overlapping, and every 5 gigahertz radio will have its non-overlapping channels. Okay, and the non-overlapping channels of 2.4 are called 1, 6, 11 are the non-overlapping channels. So for example, if this access point is operating in channel 1 for this user, it will assign a new channel to this user, so to avoid the collision between them. Similarly, if this access point is seeing some other user sitting close by in a different channel, this access point will assign a different channel. So to avoid the collision, 2.4 will have 3 non-overlapping channels. But this is for the long range, right? It is for the long range because 2.4 works in the long range. But 5 kHz is for the short range. It can only work at the short range, meaning in the conference, in a clumsy room or in a short office. If you use 5 GHz, the collision will be more because it operates at higher speeds, but at the same time it will have more collision, right? So that's why 5 GHz will have more number of channels that are non-overlapping. These are the mostly used non-overlapping channels. These are just the channel numbers that are given. Channel 30, channel 44. These are all the non-overlapping channels that are used in the wireless. Okay, but if you want the complete list of non-overlapping channels in the 5 GHz, that will be ranges from. Sorry, this is mistake. 36, not 30. It's a typo. It's 36. The total channels will be 36, 40, 44. Oh, I looked it down. So these are all the non-overlapping channels. It will have many number of channels to avoid the collision between the clients and the access points. That is why we need different channels for different users in the 5 GHz and 2.4 GHz. Okay, so to get a better idea, think about like this.
Sir, I have one doubt here.
Yeah, you can ask.
What if there are more number of access points?
Yeah, it will make sure that it is not using the same channel beside, right? Let me show you the diagram. You'll get better idea. 1 second. Let me show you that. I think you get this question. That is good. Let me do it. You see it?
Oh, got it, sir. Okay, visualizing it helped.
Yeah, so the 6 will have around like 111, 111 like that. 6 will have 111, 11. 6 will have 111, 111 like that. So non-overlapping channels will make sure the access points will not collide with others.
Got it. Okay.
Yeah, I know. I should have done a better job at drawing the diagram, but you got it. Okay. That is how we will make sure that the channels will not collide with each other. Okay. And I lost the thought there. So we have to also discuss about the SSID, the next one. So, but you guys understand the concept, right? So you will make sure you will select your antenna based on the size of the network. If it's a big room, you can put in 2.4. If it's a small room, you can put a 5 GHz. Sometimes your router will have both 2.4 and 5 GHz. I think if you order a new Wi-Fi router in your home now, you will have two names. One is your SSID name. I mean your router name -5 and the regular name without the 5. I think you might have already saw that every wireless router in your home will have two SSIDs. I mean, two wireless points that you can connect. One is ends with -5 and one is regular, and that 5 is nothing but the 5G. So if you are close to the network, if you are close to your access point, always you connect to 5G. But if your access point is in the upstairs and you are doing something in the hall in the downstairs, you might be using 2.4. If you have like a garage or a backyard, if you are doing some lawn work, it's better to connect 2.4. It depends on your house structure, right? But if you're doing in a small apartment or condo, it doesn't matter. You can connect to anything because the range will be there in both. The reachability is there both, right? So you guys understood the concept, right? Okay.
Got it. I have another doubt. Sorry to keep asking you doubts. Sometimes when we're setting up the Wi-Fi router, it gives an option to set both channels on single connection only. How does that work?
What does that mean? Can you elaborate on the question, please?
Yeah. So recently I was setting up my router. So instead of giving a separate 2.4 gigahertz channel and a 5 gigahertz channel, like you told me, it gave me an option to just set up one network. It said includes both of them, 2.5 and 2.4 and 5.
It's a marketing strategy, but when you have an antenna, if you are selecting both, that means that your both antennas are working on 5G or 2.4. So it is because you are an end user, you don't know about the technology, you blindly connected both into 5G or blindly connected both into 2.4 without knowingly or not. People think that usually a non-technical person will think that 5G is faster than 2.4. That's what they think, that's it. But they don't know the long range is a short range, right? So that's why they always try to, think that to 5G is faster, they'll directly connect to it. That's it. It is just awareness, I think.
Okay.
SSID. Okay, let's move on. So SSID is nothing but, as I mentioned, SSID is the name of your Wi-Fi. It's like it is called service set identifier. It is like a string, right? It is just a name that you can define to your wireless name that can be uniquely defined to your network. But that doesn't mean that it has to be unique everywhere. You can have your own wireless name and I can have my own wireless name and we can have the same wireless name. It doesn't matter. We can allocate that. So when you are setting up a Wi-Fi on your controller, you can put your Wi-Fi name. If you're using a small network, you will use something that you choose. But if you are using a corporate network, the corporate will give you guidelines on what name to choose, and you'll apply the name of the SSID. But in the corporate network, I think in a home network, what you will do, you will put a password, which is called pre-shared key. So if someone have that password, they can connect to the wireless signal. If they don't have the password, they cannot connect it, right? So very simple. It's called pre-shared key, PSK. Okay, but in a corporate network, having a PSK is not equally secure, right? So we have to add better security. So what can we do, guys, to add more security to the wireless with the pre-shared key? What else we can do along with the pre-shared key?
You can add a certificate.
Yep, perfect answer. Whoever told that, good job. So we'll add a certificate. So on your machine, you'll put a certificate. So if you want to connect to your Wi-Fi, the certificate have to be validated and make sure that you are the person who owns the certificate and your machine is company owned, right? So we can add a certificate that is called WPA2 encryption with .1x. If you have remembered, we touched this topic on when we are talking about AAA, authentication, authorization, and accounting. We talked about authenticator, supplicant, and authentication server. At that point, we talked about having a certificate on the box. If you did not come to the class, I think it's last week or this week, somewhere we talked about that. So go through the class, you will get better idea on that. Okay. So to make your environment more secure, we will use .1x along with the pre-shared key that will give you multi-factor authentication, right? So that is that. And then encryption. We can also do encryption. You guys already know encryption. Encryption is nothing but an encoded message that is not easy to read by any people. It is a message that is scrambled or gone through an algorithm where your data is encrypted using a key. So whoever has that key, they can decrypt the data. If they don't have the key, they cannot decrypt the data. Similarly, we can do an encryption along with the password. So even if someone know the password, they should be having an encrypted key with them, which can unlock the actual data in it, right? So we can go through an encryption, which is called, nowadays people are using AES encryption, right? That means that your data is secure, okay? So now let's see in the real time how we can actually configure this SSID, right? On a real time wireless controller, how it looks like. Let me stop share. Again, configuration is not part of CCNA syllabus, but I'm just showing you so that you will have the just regular idea on how it looks like on the corporate network. So if in your home means like you will be having only one access point, but if you are working on a corporate network, there will be many access points, right? So this is the wireless controller, which is like a centralized hub which can manage all of the access points. So I'm going to put my Active Directory credentials, my username, password to log into the machine. This is how it looks like. So for example, if I click on my access points, this will show me what are my 2.4 GHz access points, 5 GHz access points, and these are the model numbers and all of that. These are the IP address for each access point, right? So it's all good. But if to show the SSID configuration, I go to advanced. Go to wireless LANs, which is nothing but SSID, other name for SSID. So I can click on one of the SSID that we configured. So here I gave the SSID name as ASN. Its profile name, it's not mandatory. You can put any profile name, right? And then if you see, this is, I think you have to look into the security. That's where, if you see the WPA, WPA2, it is nothing but having a type of security or encryption that is allocated for you. If you see the .1x, meaning we are adding a certificate to it to allocate certificate, and then WPA2 that we did, the encryption type is AES, right? So we are doing the WPA2 encryption. The algorithm that we are using is AES, which is more secure than the older algorithms. That's how basically we will create an SSID in the controller so that it will be sent to the access points. If you have multiple access points, for example, if I show you wireless and then access points. So I have 166 access points in my network. So in my company, we are having 166 access points that I am managing through this controller. But in your home, you will have only one. So to manage all of them in a single location, we will have a controller, just like a management platform or software to manage all the access points. Okay, so that is that. Any questions?
So like one question, how will set the certificate?
The certificate will be set by the help desk or the
Okay,
PC guys,
service team.
service team. They will be pushing certificates to all the machines. But you can push a certificate. It is not a rocket science. There is a what I call it, just like an just like desktop downloads. There is a folders in the machine, right? Similarly, there is a small software called NCM or MCCM. So it depends on the Windows versus Mac, right? If you go there, you can install your certificate. Okay. Let me show you that. Hold on. Okay, I don't know. I don't have a Windows to show you, but I'll show it on the Mac. It will be very similar, but let me show you that. Okay. So if you go to Mac and if you go to a folder called keychain access, you will go to my certificates. So if you see in this system certificate, rkiran06 mac dot whatever my company domain is, right? So here, this is my certificate. If I don't have the certificate, I will be no longer be able to connect my network. So this is installed by my company safe security team. So similarly, on your laptop, if you join a company, they will also put a certificate to secure your machine.
Okay. Understood.
Good question. So
Thank you.
yeah, so that's how we will add the certificate to the machine, and then we'll make sure that that certificate is matching. Otherwise, I will be not be given wireless access or some of the internal things that I cannot do it without the certificate. Okay. Okay. Okay, we need to talk about, we talked about non-overlapping channels. We talked about SSID. We talked about RF, which is radio frequency 2.4 and 5 gigahertz. We talked about encryption. As you guys already know, we use to protect the data, we use encryption, we use different algorithms for it, right? So those are the basic concepts that they want to touch in the wireless side. This is the way they call it as wireless principles, right? They touch that. But we are not going into anything like configuring access points, configuring access point groups, configuring certificates, configuring authentication server, setting up the Active Directory. That is all something that is way out of the scope of what we can do today. That is altogether a different course, I can say. Okay, but keep these principles in mind, and in the future, if someone asks you, 2.45 GHz, at least have that idea of what they're talking. At least you will understand the core concept of it, right? So that is that. And then we will talk about the wireless security protocols, because as you guys know, we are focusing on security from past couple of days. We have to also talk about wireless security protocols, WPA, WPA2, and WPA3. So let's talk about that. Any questions before I move on to that?
I have a small question, sir. So to use the certificates, there's no need of using the office laptop, right? So we can even have it in the personal laptops.
No, because your local router does not have the capability to do a certificate authentication. If you purchase a regular router that is provided in the market, they don't do that much advanced security. Your controller, your router should support it. Then you can install and you can use it. But usually on your laptop, you can install a certificate. There is no charge of it, but the actual authentication to work, you should have a more advanced router.
In the university that I studied here, so to access the Wi-Fi there, we had to download a certificate and log in into our university credentials every time we use the Wi-Fi. So
Correct.
is that a certificate or that's some other thing?
No, that's the same certificate, yes. So on the university, they're pushing a certificate that you have to download, yes, as a local user. Yeah.
Okay. Yeah. Thank you.
Yeah, the concept is same. You got it right. So you have to have a certificate on your box, and you have to use your username, password of your university credentials, yes. But I'm talking about in your home, right? If you're in a home and if you want to set this up by yourself, I'm saying your router in your home should have that capability to encrypt you on that. You know what I'm saying? But at the university level, yes, they obviously will have the budget and they can procure all of this for you. I'm just talking, if you ask about a small home network, it is tough to replicate everything.
Yes, sir. Got it. Thank you.
Okay, so now we are talking about the security levels, right? So before we talk about WPA2, let's talk about the most basic security, which is called privacy. Okay, let's talk about that. WPE, that is the first one, which is called wired equivalent privacy. It was very old, meaning like it has only two options with it. One is no password, like anyone can access any wireless network, there is no password. Other one is pre-shared key, having a password. Right, so it's very basic. It's wired equivalent, right? But you also if someone in the, let's say this, okay. If this user wants to connect to the Wi-Fi, he can put a password, right? The pre-shared key. But if there is another user, like a hacker, if he wanted to capture the data and if you want to look into the password, he can still break it because it uses an algorithm called RC4 algorithm, which is not that secure. Okay, it is an old algorithm. It can be easily broken. For example, if you can see that encrypted data and if you can put it in the Google and then break it, any Google site will break it with the RC4 algorithm decryption method, right? So it's not secure, right? So that's why they came up with WPA, which is the Wi-Fi protected access. Meaning like it is used with the WPA. It uses better algorithm, which is called TKIP, temporal integrity protocol. So instead of, the concept is same. This guy will be using the password, but the encryption will be done with 128 bits with a longer bit encryption. Meaning they will add 128 bits to the actual pre-shared key, they will mix it and they will generate a random output that no one can actually decrypt the password. So temporal key will be using a bigger key with 128-bit keys in the web. Okay. But even that is not that secure. If someone tries for maybe 3-4 days, they can break it with the combinations, they can still break the actual password. That's why they came up with WPA2, which is the next level of WPA. They use something called CCMP. Encryption technique. So this encryption will be using the better password, like with the longer password, along with it uses the better encryption, meaning they will add more special characters to the actual password along with the length of the payload. For example, if your password is Raju, if your password is Raju, they will put they will convert the Raju R into a special character, A into a special character, J into a special character, and U into a special character, and they will add 128 bits payload to it. So even though they decrypted this to the special characters, they does not know what is the notation of the special character to the actual alphabet. So that's why they came up with the CCMP encryption, where it is better than the WPA, which is the temporary key integration protocol. And the last thing, they came up with the WPA3, which is more, better secure. It replaces the CCMP with GCMP. Sorry, I'm confused. Replace CCMP with GCMP. It's same, but it's someone guy called Galois counter mode protocol. Added better security to it. Instead of 128 bits, they increased it to 256 bits. So they added more key, a bigger key, to encrypt the data again. So this is considered as the most secure till today. They will take the password, they will change that to a special character, and they will add a 256-bit payload to encrypt the data. So it is the most secure one. So these are the security standards that we use for our password. The regular one is WEP, where it has no password, either has the password, but it is not encrypted. Even if it's encrypted with the RC4, it can be easily breakable. They came with the WPA, which will be used the temporal key integration protocol, which is better. They went with 128, but they did not do any special characters, or they did not do any markings of the data to other data, like they did not interchange with the symbols, right? And WPA2, they came with AES CCMP encryption, where they added the symbols there plus 128 bits, and WPA3 they moved from 128 to 256. So that's how they made the wireless connectivity more secure. I mean, the password more secure. But along with this, they should also use something like a multi-factor authentication, like having a certificate, having an biometric, or having an password that is like an OTP generated to the phone. They can all do that, right? So that way we can add security to the wireless passwords that we use in the network. Any questions? Okay, with that, we completed the security fundamentals. So that will be the module 5. So we are left with the last module, automation and programmability, and also fewer concepts that we missed at the network fundamentals, because we did not go through them, because those are not really fundamentals. We should be understanding little bit concepts, then we should have told them, right? So some of the concepts are missing there. So next week we're going to discuss about the automation programmability for 2 classes or 3, maybe mostly 2, and then we will cover the remaining in network fundamentals, and then we will cover the rest of the labs. One is OSPF lab, one is EIGRP lab, and one we will do with regular route table validation, next hop, path checking, like maybe 1 class for each lab. I think we will be, after that, we will be done with our course. Okay. Any questions before I just do a 1 round through the class?
So I have one question. So if you have a lot of routers which are still using the old WPA2 encryption, Is it still, do you guys still use it, or is it decommissioned and you would prefer using WPA3, upgrading all the routers in real time?
It is secure only. It is not like that old. I mean, who can break 128-bit with a password mapping? It takes couple of years to break it. If you want to break one WPA2, I think it takes 3-4 years for one password to break. It is not that old. It is not that easy to break, but it can be breakable. If someone really wants to break it, and if they want to dedicate their life for a couple of years to break it, they can break it. That's why they went with WPA3. Even WPA3, they can break it, but it will take like 4 or 5 years to break it for one password. But yes, we are still using WPA2 in the networks. It is not that depreciated. If you see, corporate networks still use WPA2. If you go to some way old networks, for example, like in the past, I worked in a company. I don't want to mention the name of the company, but it is something related to the state client. One of the state client, they uses WPA itself. They are very, very old. What they do is they do state projects like government projects. The government projects will not have any budgets. They will work on the whole infrastructure. They don't have budget to upgrade their machines because they are non-profit organizations, right? So you will, in those networks, you will see way age-old encryption technologies, and they just run like that. It's all about how much money you can spend on your technology, plus how much you can spend with your people who can know the technology, right?
Got it. Yeah.
Yeah, let me stop share. Okay, so now let's do a quick round. Varun, can you tell me what is SSID?
Yeah, SSID is service set identifier.
Okay, what is it used for?
Um,
What is it used for? Shiva, can you tell me what is SSID and what is it used for?
It is used for identifying the particular Wi-Fi network.
Yeah, it is just the name of the network where you can connect to that Wi-Fi, right? Yeah. Okay. Sriram, can you tell me what are non-overlapping wireless channels?
Hello.
Yeah.
Like 1, 6, and 11 in 2.4.
Yeah, but what are those? What are the non-overlap? What is meant by non-overlapping channel?
Wi-Fi coverage and performance. It's improve our Wi-Fi coverage and performance.
Yeah, I mean, you hit the point there. I mean, to have non-overlapping between two signals, the channels will be separating and they will increase the performance because the overlapping will be not there. Yeah. So 1611 is for the 2.4, and there is a range from 36 to the other ranges.
36, 48, 40, and those are the
5
5G.
gigahertz. Yes. Yeah.
Yeah.
Okay, that is correct. Okay. Anurag, can you tell me what is RF radio frequency?
Can you hear me, sir?
Yeah, I can hear you now.
Radio frequencies is the rate at which an event occurs. So what we are using right now is two types of frequencies that we spoke about, which was 2.4 gigahertz frequency and 5 gigahertz frequency. 2.4 gigahertz frequency is the frequency which has a longer range but slower speed, and 5 gigahertz frequency has higher speeds but has shorter range.
Yeah, that is correct. So radio frequency is the frequency of the signal that will be covered in a specific period of time. Like how many signals that can propagate at that specific period of time, right? That's the frequency. And we have 2.4 and 5 gigahertz, and you already covered about the differences between them. Okay. Kanishk, can you tell me how can we protect a corporate wireless network? How can we protect the wireless network? What are the types that we can do to protect it?
So one thing is like we can use the pre-shared key like with a certificate. So the devices which have the certificate only can access to the corporate network.
Yeah, so we can put a multi-factor authentication to
Yeah.
that, so that we can also use PSK plus the certificate.
Certificate.
Yeah.
Like
That's how we can protect it.
8 or 2.1x protocol.
Yeah, .1x protocol is used. That is correct. Okay. Monica, can you tell me what is the difference between WPA and WEP?
WEP we don't need any password, and it has two options like no password and PSK and having password. Like it provides data confidential like security, and compared to WPA, it is like the older like a old encryption method. And WPA is like the Wi-Fi protected access, and it is like a temporary key integrity protocol. They do not need any markings or interchanging the data.
Yeah, that is correct. So we pretty much covered everything. So WEP is basically has two things. It has like password or no password. WPA will work on having a better security algorithm, TKIP, but it is not that secure. It can be easily breakable. Yeah. Okay, that's good. Mahit, can you tell me what is the advancement in WPA2 and WPA3 versus WPA?
In WPA, they are adding 128 bits to the password. In WPA2, they are giving a special characters to the password that we set. And WPA3, instead of CCMP, they are giving GCMP. And adding 256 bytes instead of 128 bytes.
Yeah, that is all correct. So we will be using, instead of 128, we will be making that to the 256 in WPA3, and the algorithms will be changing from one protocol to the other to make it better secure. Okay, that is all correct. Okay, guys, that's all for today. If you have any questions, feel free to ask. You have 7 minutes of time. If you don't have anything, you're free to drop, and you guys have a good weekend.
You too, sir. Thank you. Good night.
Sir, the next class would be on Monday, right?
Yes, correct.
Okay, sir. Thank you. You have a good night.
Okay.
Yeah. Also, like, are there any books that you would suggest for these fundamentals?
Yes, I already pasted those in the first class, right? Maybe, okay, maybe you're not there. At the first class itself, I provided my blog and also the books that I suggest. Let me forward that message to you. You are in the group right now?
Yeah, I'm in the group now. Yeah.
Okay. Give me 1 second.